Okay. So this indexes is like it is very important concept for interview. Without raising questions on indexes, no interview will get finished. Okay, Nandi. So that much important indexes is, and it is also used in real time as well. Okay. So my voice is clear, right?
Yes.
Yes. Okay. Actually, I'm suffering from cold, so it will be not good somewhat. Please adjust. Okay. So here, what is the main use of indexes? We'll be discussing first. We'll be discussing about the purpose of indexes now. Okay, let me tell you a simple example. Let us consider one textbook. Okay, so if you open the textbook, there will be an index page, right? In any textbook, there will be an index page which contains all the topics of that particular book, and its respective page numbers will be there. Correct, Andy? Hello,
Yes.
hello.
Yeah.
So there because of having the topics number I mean page numbers, I mean it will contain each and every topic's page number, so that we are going to that particular topic because of that page number, right? So immediately we are going to that particular page without turning all over the all with all the pages.
Correct.
Correct. So there we
Yeah.
are going to, I mean immediately we are seeing the data, we immediately we are fetching that particular data, right? So there we are saving our time because of having that index page. Correct, Andy?
Okay.
So in the similar way, in our SQL server also indexes will work. Like the main purpose of using the indexes here is we can retrieve the data faster from the table. Okay. So generally indexes will be created on top of the table. Specifically, we are creating indexes on top of the columns. Okay. So whenever you create indexes on top of the table, then you can retrieve the data faster from the table. Okay, if for example, if our table contains some thousands of records, then we can retrieve the data faster. If it contains some lakhs of records, means in real time it will obviously it will contain some lakhs of records in real time. So at that time you wrote a select statement and you are applying some conditions and you are trying to retrieve the data. Okay, at that time sometimes it will take, I mean query execution will take some hours to hours. So at that time our time will be wasted, right? So just to display the output from the table, it will take some hours of hours. Okay, so at that time, what we have to do is we have to go and create index on top of the table. Okay.
Okay.
So if we create index on top of the table, then we can retrieve the data immediately. Like we can quickly retrieve the data so that our time will be saved and also the particular query performance will be improved. So indexes will also comes under a query performance technique. Okay. You got it right.
Yes.
Yes.
So that now the thing is we know the purpose of creating the index. Like generally how we will be creating constraints, Andy? We'll be creating constraints on top of the table, right? In specifically we are creating constraints on top of the columns. Correct?
Yes.
In the similar way, indexes will also be created on top of the columns. Okay. So now we will be discussing about the backend things. Like whenever you create index on top of one particular column, then what will happen in the backend? Okay. So all those things we'll be discussing now. So how we are, so I'm telling like if we create index on top of the table, then we can retrieve the data faster. But how? We don't know, right? So anyone have idea? Like Harish bro, you are a DBA, right?
Sorry,
Mm,
I was on mute. Yeah, I have idea on index.
hello?
Yeah, I have idea on indexing.
Yes, that's what I'm asking you. Okay. So as a developer and as per my understanding, I'll tell you. So if anything, I mean, if you know any extra things means, then you can please share
Yeah,
with us. Okay.
definitely.
So now we will discuss about the backend things which will happen in the I mean whenever you create index on the top of the table, then what will happen in the backend. Okay, so in this topic, in this indexes topic, we will be always hearing these two terms, which is seek and scan. Okay, so whenever you write a select statement to retrieve the data from the table, so always there will be an execution plan happening in the backend. Execution plan is nothing but what are the steps performing to get the data. Okay. So there we will be listening, we will be hearing this seek and scan terms. Okay. So let me tell you what is mean by seek and then what is mean by scan. Okay. Just consider an example with few records and few columns. Okay. So in this example, what I'm trying to do is I'm trying to retrieve this particular third record. Okay. So for this, I wrote a select statement to retrieve this particular third record. Okay, so now in the execution plan, sometimes scan might happen, sometimes seek might happen. Okay, so if scan is happening in the backend means then what is happening in the backend means scan is nothing but, so whenever we wrote a select statement to retrieve this particular record, if scan is performed means what it means it will scan all the records in the table and then it will fetch the record whichever we want. Okay. So that is nothing but scan. If in the execution plan, if the seek is getting performed means it is directly going and fetching the particular record without scanning all other records in the table. Okay. Directly it will fetch the particular record whichever we specified in our condition.
Okay.
Okay. So here now in this example we haven't created any index on top of any column. So this particular table is called as heap table generally. It will be termed as heap table. Okay, in case if we created any index on top of any column means then that particular table is called as indexed table. Okay, Nandi?
Okay.
So generally if we create index means then the ultimate goal to be our ultimate goal is to get performed seek only. Okay, because if seek in the execution plan, if the seek is happened means what it means, it is directly going and fetching the particular record without scanning all other records in the table. So in that way we will be retrieving the data faster immediately because it is not scanning all the other pages. Like if we take our textbook example, because of having the address of the particular each and every topic in the index page, it is going and directly it is we are going to that particular page and then we are seeing the data, right?
Yes.
So there the page number is address. Here also we will be having address whenever we create index on top of any column. I will tell you that later. Okay, but our ultimate goal is to perform seek. Okay.
Okay.
If scan is getting performed means there is no use because it is scanning all the other records in the table.
Okay.
Okay. Okay. So now I'll tell you the different types of indexes whichever we have. Okay. We have clustered index and also we have non-clustered index. These two are the major indexes which will play a key role. And also we have covering index. Okay. As a developer, we should be aware of all these indexes. Okay, Randy?
Okay.
So first we'll discuss about this clustered index. Okay. So generally all these indexes will be created on top of table, specifically on top of column. Okay. So this is the common point for all the indexes. So first we'll discuss about this clustered index. So what is the use of this clustered index means? So whenever you create clustered index on top of any column, like what it will do means it will sort the data in a physical order as like primary key. Okay, Randy. So whenever you create primary key, by default clustered index will be created, right? So
Yes.
while discussing about primary key, I think Harshad might tell you.
Yeah, I told us.
So that is the thing, because both have the one similar property, that is sorting. Okay.
Okay.
So and the preferable column to create clustered index is numeric column, integer type of column. Okay, you can create on other type of other data type columns also, but the preferable is integer. Okay, Nandi?
Okay.
Okay. So next thing is, can you create multiple primary keys on top of a single table?
No.
Why? Is there any reason?
You can assign it only to one column, primary key.
Hmm?
It can arrange in only in one order.
Okay. What
You can
will happen if we create one more primary key on another column in the same
It
table?
won't allow us to create on two columns.
Yes, it won't allow us to create on two
It will
columns. It
throw
will
an error.
throw some error. Okay, fine. So in case if we try manually to create primary key, not in SQL Server, just if we try to make down in
Be
nodes or something.
confused, like in which order it has to consider to sort or.
Okay, because the reason is like you, on top of one column already data gets sorted and their respective records will be arranged. So if we create one more, I mean, if we create one more primary key on another column, means that a particular column, in that particular column, data also will get sorted, right? So at that time, data will get shuffled. Correct, Adi?
Yeah.
So that's why we should not create multiple primary keys on a single table. So in the similar way, we cannot create multiple clustered index on top of a single table because of having its sorting property. Okay. We
Okay.
can create only single clustered index on top of a single table. Okay.
Yeah.
Okay. So this is the first thing which we have to remember whenever you are creating the clustered index on top of any column. Okay. And the second thing is, this is the main thing. So whenever you create clustered index, right? So at that time, what will happen in the backend means, I'll tell you with an example. For example, let us consider we have some 4 columns with some records, okay, with some 1,000 records. So now this table, on top of this table, we haven't created any index. Then what it is called? What this table called? It's called as heap table, right?
Heap
If
table.
yeah, if you don't have any index on top of any column, then it is called as heap table. Okay. So whenever you go and create clustered index on top of any column, okay. So at that time, that table is known as indexed table. And whenever you create a clustered index on top of any column, in the backend, SQL Server will do means it will create one more structure, including all the columns along with data. Okay. So for example, let us consider we create a cluster index on top of first column. Okay. So all this will happen in backend. We don't know anything, like we cannot see in front end.
So it will create one more table, or it will rearrange the data on the
No, no.
particular.
In the backend, it will we cannot see the tables which is created again. Just we have to imagine all the things. What is going to happen in the backend? It will
So we have to
create
tell
one
that it
more
has been
structure.
rearranged.
Yes, yes. Yeah, kind of. So it will create one more replica, including all the data, all the columns along with the clustered index column and also data.
Okay.
Okay. So this is the second step which is going to perform in the backend. Okay, Nandi? So
Okay.
then what is the difference between these two tables? What is the difference between main table and indexed table? We don't know, right? So why
Yeah.
it is creating one more table along with all the data means, because what is the use of index? It is going to retrieve the data faster. Whenever you create index on top of any column, the main goal is to retrieve the data faster, right? But so whenever we create a cluster index on top of one column, then it will create one more structure with including all the columns and data, and then it will assign address for each and every record which are there in the clustered index column. So for this 101 to 1000 records, it will append addresses for these values, not for other values, not for other column values. Only for this clustered index column values, it will append addresses. Okay, generally that addresses will be denoted with row ID, or we can say it as RID. For this first record, it will assign one address that is denoted as RID generally. Okay. For this 102 record, it will append one more address that is RID2. Similarly, it will assign address for each and every value in the clustered index column. So whatever the values we have in the clustered index, for all those values, it will assign one address. Because of having address only, we will be retrieving the data faster. Okay. అర్థమైందండి? So in the similar way, it will assign for all the records in the table. Okay. So whenever you create cluster index on top of one column, then it will create one more structure, including all the columns in the table along with data. And only for the cluster index column values, it will assign addresses for each and every value in the table. Okay. All these addresses will be appended only for the clustered index column values, not for other column values. Okay, Nandi.
So we have to use this column in where condition to retrieve data faster, right?
Yes, yes, correct. I will show you that later. Okay. As of now, got it, right?
Yes.
Okay. So after now it assigned the addresses for these values. So now the thing is, so in SQL Server, after assigning the address, what it will do? What it will do means SQL Server have to store this data along with these addresses somewhere, right? So for that, it will follow inverted binary tree mechanism to store this all the table values, table data, and then to store these values and then addresses. Okay, so how it will follow means, so it will follow inverted binary tree mechanism. Generally, binary tree mechanism means what? Like on top, we will be having leaf nodes, on bottom, we'll be having root nodes. This is reverse to that binary tree structure. Okay, so this SQL Server will follow inverted binary tree mechanism to store the actual data and to store addresses of the clustered index column values. Okay, so why it is following this process means, to retrieve the data faster, it is following this process. Okay, Nandi.
Okay.
So here we will be having root nodes on the top and then leaf nodes on the bottom. Okay, so all these are pages. Okay, so first I'll tell you about these root nodes. In these root nodes, what is going to be stored means, so it is in this example we have 1,000 records, right? So
Yes.
for all these 1,000 records, this particular cluster index column values have addresses as well, right? So this particular index column values have addresses. All those addresses will get stored in this root node. Only addresses will get stored in root nodes, not data, not columns, other columns data or cluster index column data. Only the addresses of the cluster index column values will get stored here. Okay. అర్థమవుతుందా?
Yeah.
Yes.
Okay, so now these particular addresses will be splits into the intermediate nodes. Here also, in these intermediate nodes also, addresses will get saved. Only it will split these addresses into number of nodes, depends upon the address values. Like the depends upon number of records. Okay, so after that, in these leaf nodes, what we will be having is, we will be having the whole table data in the leaf node. Okay, like all these are the pages. Generally, where data will be stored only in SQL Server.
In pages.
In pages only, right? Physically, it will be stored in the pages, but logically, we are representing in the tables, right?
Yes.
So actual data will get stored in the in the pages. So that's why whenever you create clustered index, all clustered index values addresses will be stored in the root node, and then it will split all the addresses into intermediate nodes, and in leaf nodes the complete data will be getting stored in the leaf nodes. It depends upon number of records, it will split. Okay, Nandi. So that's why this is called as databases as well, because it contains the actual data. Okay. So here we will be having all the data, all columns data will be present in all pages. Okay. So now in this particular first page, we have some, based upon these addresses, it will split the data into different pages, right? So in the first pages, we have some 1 to 100 records, and then 101 to 200. Depends upon the records, it will split into the pages. Okay, like that up to till from 1 to 1,000 records, all data will be available in these databases. Okay, now the thing is, now if, for example, if you want to retrieve some 150th record, or let us consider, now we want to retrieve this particular 100th record from this table. For that, we wrote a select statement by specifying some condition, like so column 1 equal to 100. Okay. So at that time, it needs to get this particular record in the output, right? So at that time, so now we create a cluster index on top of one column. So because of creating cluster index on top of this column, all these values addresses will get stored in the root node, and remaining data will be stored in the leaf nodes. Correct, Andy? So now we need to fetch the 100th record. So at that time, it will, so it is already following the inverted binary tree mechanism. So now how it will fetch the data, I mean, how it will fetch the 100th record. So now for this 100th record, it has an address, right? We are applying filtration on top of clustered index column to get this particular record. అర్థమవుతుందా లేదండి?
అర్థమవుతుంది.
Okay, now we want to fetch this 100th record, and on top of this, I mean, we are applying filtration on top of this clustered index column only. So at that time, what it has to do? So this 100th record have the address, right, in the root node. In the root node, we will be having all the addresses, right?
Yes.
So because of having address here, so directly it will point to this intermediate node. Correct, Andy? So 100th record address will be there in this intermediate node. Correct? And then it need to fetch the actual record, right? So all the records, all the data will be present in this leaf nodes only. So where the 100th record will be present, it will present in this first page only, right?
Yes.
So now what it will do means, in the execution plan, it will perform seek operation. Why it is performing seek operation means, because of having it address in the root nodes, it is directly pointing to the actual data. So that's why it will perform seek operation, and it will fetch the 100th record directly without scanning all other pages in the table. Okay. So at that time, time will be saved, right? Because it is not performing scan operation. It is performing seek operation. Why it is performing seek operation means, because of having its address in the root node, it is performing seek operation. Okay, so addresses and data, I mean, addresses is storing in the root nodes and remaining data is stored in the leaf nodes, means it is following inverted binary tree mechanism. So inverted binary tree mechanism is following means, we have created some index on top of some other column, some one column.
Okay.
Okay, so if we take the textbook example also, there we have the topics page number. So that is nothing but address. Because of having the address only, we are directly going to that particular page. So in the similar way, in indexes, I mean, in databases also, in SQL Server database also, because of having addresses, we are fetching the data immediately. Okay. And next we have non-clustered index. Okay, Nandi. So why we have to create this non-clustered index, and what is the difference between clustered and non-clustered means? Generally, whenever you go and create, so whenever we cannot create multiple clustered index on top of one table, at that time we will be going to create non-clustered index on top of that column. Okay. I will show you that with an example. Okay. And whenever you create non-clustered index on top of any column, data will not be getting sorted in a physical order. Okay. Data will be as it is. Okay, just if we are going and creating non-clustered index on top of any column means, then what will happen in the backend means, generally what will happen whenever we create cluster index on top of one column, it will create one more replica including all the columns data, right?
Okay. Yeah.
And then it will assign addresses to each and every record in the to each and every value for non-clustered, I mean, clustered index column. Correct. So whenever you go and create non-clustered index on top of one column, then what will happen in the backend means, for example, let us consider I have created non-clustered index on top of this column. Okay, the backend, what is going to happen means, for example, I created non-clustered index on top of the column. So at that time, what SQL Server will do means, it will create one more structure as like clustered index only. But the thing is, it will create one more structure including only that particular indexed column. I mean, that particular non-clustered index column. It will not include all other columns in the table. Okay, just it will go and create that particular non-clustered index column only. Okay. Arthamainda difference. And then it will assign address for each and every record in the table as usual. Okay, if we are going to create in an index means, then the main thing is, it will to assign addresses for each and every value in that particular column only, then we are going to create index. Okay, so and then it will as usually append addresses for each and every record in the non-clustered index column. Okay, like in a similar way. Okay.
Okay.
So the main difference between clustered and non-clustered is whenever you create clustered index in the backend, it will create one more structure, including all the columns along with clustered index column and all the data. Okay. And only for clustered index column values, it will assign addresses. Okay. But whenever you create non-clustered index on top of any column, what will happen means it will create one more structure, including only non-clustered index column, not other columns. It won't include any other columns. Okay. And then it will, as usually, arrange the append the addresses for each and every value which are there in the non-clustered index column. Got it? And next step, what will happen, I mean, after creating one more structure, whenever you create cluster index, what will happen, it will follow inverted binary tree mechanism to store this all data and then to store the addresses of this particular cluster index column value, right? So in the similar way, whenever you go and create non-clustered index, after appending addresses for each and every non-clustered index column value, it will follow inverted binary tree mechanism only to store this all addresses for non-clustered index column values and to store this data. Okay. So it will follow same inverted binary tree mechanism. But the main difference is, so in this root node, what will be getting stored? These particular column values, addresses will getting stored in the root node. Okay. In the similar way. So whenever we create cluster index, what is happened? So whatever the values are there in the cluster index column, for that column, values will be stored in the root node, right? In the similar way, whenever you go and create non-clustered index column, so there you will be having these non-clustered index values, right? So for all these values, they have some addresses. All these addresses will get stored in the root node, and then it will split into the intermediate nodes. And in the leaf node, what it will contain means it will contain only non-clustered index column values data matrame. Okay, it will contains only these column values. Okay. So in the leaf nodes, we will be having only non-clustered index column values. Okay. Okay, Nandi. So that's why these particular leaf nodes are called as index pages here. But when it comes to the clustered index, these leaf nodes will be called as data pages. Why? Because means it will, whenever you create cluster index, it is creating one more structure, right? So all the data will be stored here. So that's why it is called as data pages. But whenever you create non-clustered index, it will contain only that particular non-clustered index column values in the leaf nodes. That's why it is called as index pages here. Okay, Nandi?
Okay.
So this is about clustered and non-clustered index. Okay, Nandi. So I will tell you I will tell about this covering index while telling you an example. Okay. So మీకు అర్థమవుతుందా అండి పాయింట్ ఏంటి అని ఎగ్జాక్ట్?
Yeah.
Yes.
Okay, please note down the content for these indexes. So first point, indexes are used to retrieve the data faster from a table. Indexes are used to retrieve the data faster from the table. Next point, by using indexes, we can able to improve the query performance.
We can able to perform.
We can able to improve the query performance. Next point, non-indexed table is called as a heap table.
Can you repeat it?
Non-indexed table is called as a heap table. Next one. Next one. If we have less amount of data, then it is fine to retrieve the data. But
Then it's okay. Then it is fine to retrieve data without index, something like that, right?
yes, if we don't have index at that time, even if they have, if we have less amount of data, then it is good to retrieve. But if we have huge amount of data in the table, then query performance will get slow. By doing table scan. Or scan.
But if I use amount of data, then
What, bro?
what was the last line? But if we have huge amount of data, then
Query performance will get slow
okay.
by doing scan. So at that point of time, we will go for indexes. Done, Andy?
Yeah.
Next, note on the difference between seek and scan.
Okay.
So first, make a side heading as table seek. So generally, if you don't have any index on the table, at that time, if in the execution plan, it will happen seek and scan, right? So generally, it will be called as table seek and table scan if it doesn't have any indexes. If we have any index on top of any column, then it will be, and then if you see the execution plan, there it will be indicated as index seek and index scan. Okay, now.
Okay.
So first note down table seek. Table seek means what it will do, it will directly go and fetch the particular record without scanning all the records in the table. It will directly go and fetch the particular record without scanning all other records in the table. Next, put side heading as table scan. Next, table scan means it will scan all the records in the table and then it will fetch the particular record whichever we want. It will scan all the records in the table and then it will fetch the particular record whichever we want to retrieve. Done.
Yeah.
Next, put side heading as conclusion. So we can conclude that table seek is faster than table scan. Aunandi? So
Yeah.
seek is faster than scan, right? Because it is directly fetching the particular record. So this will be one of interview questions sometimes. Table seek is faster than table scan because it will fetch the record directly. Next, we have different types of indexes. First one is clustered. Next, we have non-clustered and then covering. Please put side heading as cluster index. First point. Whenever we create cluster index on top of the table, whenever we create clustered index on top of the table, data will get sorted in a physical order. Data will get sorted in a physical order. Full stop. So that clustered index can be created only one on top of the table. So that clustered index can be created only one on top of the table. Next point. Whenever we create clustered index on top of the table, comma, whenever we create clustered index on top of a table, comma, in the backend, one more structure will be get created, including all the columns in the table. Whenever we create clustered index on top of a table, comma, in the backend, one more structure will get created, including all the columns. Next point. Whenever we apply clustered index on top of the table, it will follow inverted binary tree mechanism. It will follow inverted binary tree mechanism to store the actual data, and to store the addresses of a particular indexes. To store the actual data and to store addresses. Done, Andy?
Yes.
Okay. Please represent this in your books as well, if you want. In the root nodes, we will be storing the addresses, and in intermediate nodes also we will be storing the address of a clustered index column values, and in these sleep nodes, actual data will get stored. Done, Andy.
Yes.
Okay. Now we want to create cluster index on top of one column. Then we have a syntax to create it. Just we need to start with create. We'll be creating cluster index, and then we have to specify the index name here. Okay, as like constraint. Okay, create clustered index name on top of which table we are going to create it. Okay, that particular table name we will be specifying here. And in the table on top of which column we are going to create, that particular column name we have to specify here. Okay, Nandi? Create cluster index, and then we will be providing the index name on top of which table we are going to create index, and on top of which column we are going to create index. That we have to mention. Okay, you can note down the syntax. Complete అయిందండి.
Yes.
Next, keep side heading as non-clustered index. First point, we can create multiple non-clustered indexes on top of a table because it doesn't have sorting property. We can create multiple non-clustered indexes on top of the table because of not having any sorting property. Next point, whenever we create non-clustered index on top of any table, I mean any column, whenever we create non-clustered index on top of table, you can specify it as table, comma, in the background, it will include only that particular non-clustered index column. In the background, it will include only that particular non-clustered index column with data will be created. With data will be created. And then you can represent this diagram. This is similar to the non-clustered index, but the only difference is in these sleep nodes, whenever you create non-clustered index on top of any column, it will store only that particular column data here. So that's why it is called as index pages. You can make this difference.
Usha, please excuse me. I got one more deployment at 7 o'clock. I need to drop here.
Okay. So you are working
I'll
today
take it out
also?
from Hemant or Hari Krishna.
Yeah, sure, no problem.
Yeah, thank you so much.
Thank you, bye.
Bye.
You both people don't have office, right, today?
Today it's my week off, Usha.
For you, Hemant?
I'm not.
Okay. So no problem, right? It will take 1 more hour, I guess.
Yeah.
Okay. సో డన్ అండి ఇది. కంప్లీటెడా?
Yes, Usha.
Okay. So now I'll show you practically like how to create index. What will happen whenever we create index? What will happen in the backend? I'll show you the execution plans as well. Okay. Let me open. Okay. So I have created an index database with the name of index. Here I have some tables. I'll take this table now. So just I'll see the data from this table. Yes. So here I have some 1,000 records in this table. Okay. So I have some 1,000 records. Now, now I need to retrieve some one particular record from this table. Okay. Let me specify condition as column 1 equal to some, let us consider we will be retrieving this 100 record only. Okay, Andy? Now, do we have any index on top of this table?
No.
No.
No. Okay. Well, let's check on. Okay. So if you click here, so generally how we will be finding columns, keys, constraints. In the similar way, we will be having indexes here. Okay. So if any indexes are created on top of this table, then it will display here. Okay. So as of now, we don't have any index here. So we don't have any indexes created on the top of this table. Okay, Nandi. So now if you execute any select statement, okay, any query, if you want to see what is going to happen in the backend, I mean, what is the execution plan it is taking to execute this query. So if you want to see that means, then you have to enable the actual execution plan, which you can see here. Okay, so you can enable in this way, or else you can press Control N. Okay, Nandi. So after enabling this, you need to execute the query. Okay. So just to see the execution plan, we are enabling this. Okay, Nandi. So if you see here, so now after enabling the execution plan, if you execute the select query, then we will be getting result tab, and then usually we will be getting results and messages tab, right?
Yes.
So in the output, now we get execution plan as well. So if you click on this execution plan, you can see what is going to happen, what is happening in the backend. Like what it is performing now. If you hover your cursor here, then you can see many things which is happening in the backend. Okay. So first let me tell you what is happening here, which operation is performing here.
And
It is performing table scan, right? Here you can see table scan, right?
yes.
So table scan means what it is doing. To fetch this particular 100th record, it is scanning all the records in the table, all other 999 records as well, to
Yes.
fetch only this particular record. Aunandi? So if you hover your cursor here, you can see 1, 2, 3, 4, 5, 6. Just go to the 7th line. I'm not able to show you here. I'm not able to place my cursor there. So there is a number of rows read, right? Number of rows read and actual number of rows, 6th and 7th line.
Yes, 1,000.
So it is reading 1,000 rows because we have 1,000 records in the table. Okay. To get one record, it is reading 1,000 records. Okay. Actual number of rows is nothing but how many records we are retrieving, how many records we want to retrieve. So whatever we are specifying in our condition, that particular value will be there. Okay. So to read only one record, it is reading 1,000 records. Okay, Nandi. So that's why it is indicating it is scanning rows from the table. Table scan is nothing but it will scan all the records in the table. Okay.
Okay.
So because of this, we don't, I mean, here we have only 1,000 records, so that we got data immediately within fraction of seconds, query is executed, right? See, if you see here, within 2 seconds, we got the data. But what if the table contains some lakhs of records? Obviously, it will take some hours to hours in real time just to display this particular record. Okay. So at that time, what we are going to do means we will be creating index on top of this table. Okay, because whenever you create index, what will happen? It will automatically append the addresses to each and every column on the top of the indexed column. Okay, so because of having address only, we will be retrieving data immediately. Okay, so now what we will do is we will just create a index on top of this any column. Okay, Nandi.
Okay.
So how to create clustered index?
Create trusted index
And then
Index
we
name
will
and
and
type.
index name.
So general index names will be specified as per our wish, but how we will be creating constraints, Andy? We will be creating constraint names, right? So it will be like if it is check constraint, then CK underscore and
Yes.
table name. So in the similar way, we will be creating the index. Okay. Generally in my company, we used to represent cluster index with IX. We start with IX.
Okay.
Okay. So there is nothing but clustered index, indication of this particular clustered index. Okay, just we are so if we see the index name, then we will get to know which type of index it is. So okay, for that, if it is a clustered index, then we will start with IX and then we will putting the table name on top of which table we are going to create the clustered index, and then on top of which column we are going to create the clustered index. Okay. Now I will create on top of the first column because I'm applying filtration on top of this column 1. Okay, Nandi. So this will be my index name. Okay. And on top of which table we are going to create? On top of this sample data, we are going to create index, and on top of which column we are going to create index? On top of column 1. Okay.
Okay.
So now we will execute this. We will get the index will be created. If you want to see, you can refresh this. Now, if you see here, index is created, right?
Yes.
Which is it? It will also denote it is a clustered index. Okay, Nandi?
Okay.
So now what we will do is we will fetch this particular so now we will fetch this particular record. Okay, we will execute the same query again. So after that, we will see the execution plan, what is going to happen in the back. Okay, so obviously we'll be getting this record, right? So here we have 1,000 records only, so that's why we are getting the data within fraction of seconds. Okay, but in real time we will be having some lakhs of records. At that time only these indexes will help us. Okay, so now if you see the execution plan, what is happening here? So which type of operation is happening here? Before creating index, it is performing table scan, right? Scan is nothing but
Yes.
scanning all the records. Now it is performing index seek, clustered index seek. Okay, generally seek is nothing but it is directly fetching this 100th record. Okay.
Yes.
Okay.
So we created clustered index, right? So that's why it is showing as clustered index seek. If we create a non-clustered index on top of the one column and then we are trying to retrieve the data, means at that time in the execution plan it will be displaying as non-clustered index seek will be performed. Okay.
Okay.
As of now, here index is happening means if you see here, so
Number
now
of
see
rows
number
read.
of rows, so actual number of rows, only
Yes.
one. So to retrieve one record, it is directly reading one record because whenever you create a cluster index, what is happening in the backend? So all these steps we have to imagine. That's it only. Okay.
Create another structure.
Another structure, and for the clustered index column values, it has the addresses. So all these addresses and data will be stored in the inverted binary tree mechanism. Because of storing in this way, we are retrieving the data faster. Directly, it is fetching that particular record without scanning all the records in the table. So in this way, we will be retrieving the data faster. Okay.
Okay.
ఓకేనండి అర్థమైంది ఇక్కడ
Sardoni.
Okay, so now the thing is so for example, now we apply filtration on top of this column 1 and we are trying to fetch the record. At that time index seek is happened, cluster index seek is happened. So what if we apply filtration on top of another column? Okay, like column 2 or column 3 or column 4 for example. So now I need to is this particular record. Okay, now also we'll be getting the same output, avuna andi? Because column 4 have this value, I'm just applying filtration on top of column 4 to get this particular record. Okay, and if I'm specifying star means it needs to read the data from all the columns, right? So if you say you read this data, you will be getting the same output, right? Just I changed the condition here, like I want to retrieve, I'm just specifying the condition to retrieve data from column 4. But here star indicates to get all the records from all the columns, right?
Yes.
So now if you execute this query, so his execution plan will change or it will be remain same? So if you see the execution plan, what is happening here?
Scan.
Index scan is performed, right? So scan
Yes.
is nothing but obviously it will scan all the records. If you see here, so how many number of rows read and actual number of rows are there? It
1000
reads
numbers.
1000 records. Scan is nothing but it is reading all the records, and to get fetch only one particular record, it is reading all 1000 records again. So no use of by creating index, right?
Yes.
So why this can happen means we have index on top of column 1, but not on column 4. Correct, Andy? If we
Yes.
if we doesn't have index on top of this column, means it will it have addresses and on root node? No, right?
No.
So only this column 1 values have addresses in the root node, but column 4 values doesn't have any address. Generally, this data will get stored only in the leaf nodes. Okay. So that 100th record will be stored in the leaf node, but it doesn't have addresses in the root node. So because of not having address, it is obviously it is scanning the all the records. Okay.
Okay.
Arthamainda point.
Yes,
So now what we have to do? If we go and create one more clustered index on top of any other column. So for example, if we create clustered index on top of this column, we can create, if we create cluster index on top of this column and if we apply filtration means, then obviously it will do perform seek, right? Because we created cluster index on top of this column. But can we create one more cluster index on top of this column?
No.
No, because
We can only create one.
we can only create one. So if you try to create one more, I mean, for example, if you try to create one more clustered index on top of this column 4, okay, so obviously it will throw an error. So let me execute. If you see here, as like primary key, we cannot create one more cluster index on the table. If you want to create, then you have to drop the cluster index and then you have to create one more. Okay, Andy?
Okay.
So in this scenario, we need to apply filtration on top of this column 4 only, but execution plan should be performed as a seek. Okay, so at that time, what we will be doing and what we will be doing is we will be creating non-clustered index on top of that column. Okay. So if we create non-clustered index on top of one column, what will happen?
The specific column will structure will again
Get created
created.
and for only this particular non-clustered index column values contains addresses in the root nodes. Okay.
Yes.
So now we create non-clustered index. It is say, I mean, it is similar to, okay, it is similar like creating clustered index only. Okay, but we have to specify here as non-clustered index, or else we can specify as index. If you specify as index, it will create non-clustered index in the backend. Okay, Nandi. So if you specify the index name as not index name, if you specify as clustered index, it will create clustered index. If you specify as index or non-clustered index, then it will create non-clustered index. Okay. So you can specify as non-clustered or you can specify simply as index. Okay, Andy. So generally, whenever you are going to create non-clustered index name should start with NIX. Okay. So this is just for our identification. Okay. So we will be creating non-clustered index on top of this table, and then on top of this fourth column, we will be creating. Okay. So just I like this. So now if you go and see here. So one more. non-clustered index is created. One more index got created. Avunandi? So clustered and then non-clustered. Okay. So now, if you now on top of this table, we have two indexes, which is one is clustered on top of one column, column 1, and then we have non-clustered index on top of column 4 as well. Okay. Now we are going to apply filtration on top of column 4, which have non-clustered index column, which have non-clustered index. Okay. Now, if you see the execution plan, can you expect like what is happening in the execution plan? Will it perform seek or scan?
Seek.
Seek. Obviously, if we have created index on one particular column and then we are using that column in the filtration, means obviously in the execution plan it will perform seek. Okay, Nandi. So if you see here, we have there are two steps, which is index seek and key lookup as well. So if you come here, so how many number of rows read and actual number of rows returned?
Only one.
Only 1 and 1, because here it perform non-clustered index seek. Okay, Nandi. And also, if you see here one more step has been performed, which is a key lookup. Okay, so sometimes interviewer will ask about key lookup as well. So what is mean by key lookup means, what this key lookup is doing means, if you see here we have output list, right?
Yes.
So in this, for this, what I mean, why this key lookup is being performed means, to get column 2 and column 3 data, it is performing key lookup. Okay, it means, so if you see here, on top of column 1, we have clustered index. On top of column 4, we have clustered index. Correct, Andy? Only for these two column values, it has addresses. Because of having addresses, it is directly fetching this 100th record and then this particular value. So if we specify star, it needs to get all columns values, right? So on top of this column 2 and column 3, we don't have any indexes, right? It will be contained in the leaf nodes. How, Andy?
Yes.
Now it needs to retrieve this column 2 and column 3 data value, column 3 data values as well, right? So to get this column 2 record and column 3 record, it is going to perform key lookup. Okay. So this is a clustered index column. That's why it is included already. And on top of this column 4 also, it have non-clustered index. So that's why it will come automatically. But to get this column 2 and column 3 values, it is going to perform the key lookup here. Okay. But this is also somewhat, this will also degrade the performance of the query, because our ultimate goal is to perform only C. Okay. It should not perform any other steps in the execution plan. But this key lookup is performance, it is also somewhat, it will also somewhat degrade our queries performance. So that's why what we have to do is, we have to go and create covering index. Okay. So we have one more index, which is covering index. Covering index is similar to non-clustered index only, but whatever, when we have to create this covering index means, whenever it is performing key lookup in the execution plan. Okay, at that time, what we have to do is, we have to include those particular columns in the non-clustered index column, right? In this way. So it is similar, non-clustered index. Here, what we have to do is, we have to create non-clustered index with some different name. So, and then we have to include, what is this? So just we have to use the keyword include, and then for what it is performing lookup, to get this column 2 and then column 3 values, right? It is performing key lookup. So that's why we have to include those particular columns in the non-clustered index column. So while creating non-clustered index, at that we can include the particular columns which is reference.
Yes.
So this is nothing but key lookup is nothing but it is just trying to retrieve some other columns data as well, which doesn't have any index. Okay, so at that time, if any key lookup is performed, at that time we have to simply create the covering index. Covering index is nothing but just it will include other columns into the index pages, so that it will perform seek operation directly. Okay, so now just I will create this. Cannot use duplicate column names in an index. Column 4 listed more than once. Okay, so here it is
2 and column 3.
2 and column 3, right? Okay, so now we will retrieve this particular record. If you see the execution plan here, it's performing only index seek now.
Seek.
Okay, so this is how covering index will help us. Okay, so our ultimate goal is to perform index only index seek. It may be non-cluster index seek, or it may be cluster index seek. Okay,
Okay.
this is the use of covering index.
So with,
Okay.
these three indexes, we can get all the information on entire the row.
Yes, entire records. I mean,
Okay.
all columns records.
Yes, yes.
Okay, so in real time, just if the table contains some huge amount of data, at that time we will be just creating index. Any index you can create. Okay, you can start with non-clustered index, or you can create a clustered index. Okay, and then we will be retrieving the data, because it will directly fetch the data for us. I mean, we can retrieve the data fastly from the table. You know how to retrieve, I mean, how it is retrieving the data, because of storing the addresses in the form of inverted binary mechanism. Okay, Nandi?
Yes.
So
Can we retrieve multiple rows?
you can retrieve multiple rows. You can retrieve I mean, you can specify any number of columns here. But the thing is, if you create index, then obviously it will perform seek. So seek is performing means we can retrieve the data fastly. Okay. Simply we will be blindly going and creating the index on top of the columns which have some huge amount of data. Okay. But for in the interview case, interviewer will expect from us to be explained all the backend stuff which will happen in the whenever you create index.
Okay.
Okay, Nandi. So
Okay, I have a doubt, Usha, here.
yes, you can ask.
So we have created, a non-clustered index for column 4, right?
Yes, correct.
Instead, creating this covering index, we can create column 2 and column 3 as non-clustered index. Is it possible?
Directly we cannot create at a time. We cannot create. We can create once again. Like once you create one index on top of one column, and again we need to create it. So without that we can create covering index, right? We can include all the columns whichever we want. We can specify number of columns whichever we want in the non-clustered index column. I mean, while creating non-clustered index, you can create again and again. And also, if you want to create non-clustered index on top of one table, we can create multiple, but it has some limitation. Like till 299, we can create. I mean, 299 non-clustered indexes will be we can create on top of one table.
Okay.
I think that is the limitation, but I'm not sure about the actual number. Okay. But clustered index means it will be created only one. Okay, Nandi.
Okay.
So for non-clustered index, have you noted down the content?
Yes.
Okay, you can note down the syntax as well. It is similar to clustered index, but you can specify non-clustered index, or else you can specify index. Sometimes interviewer will ask basic questions also, like if you he will tell you the query like this, like create index name and some table name, then which index is created in the backend. So if it is only index, then non-clustered index will be getting created. Okay. You can specify as non-clustered index, or you can specify as index. Next, make side heading as covering index. Note down the content. A covering index is a non-clustered index. A covering index is a non-clustered index which includes all the columns referenced in the query. Which includes all the columns referenced in the query. You can note down this index. Done, Andy?
Yes.
Hemant.
Wait,
Okay.
it's done.
And you cannot create the similar index names. Okay, so at least you have to make a simple difference there. Okay, because it is also index is also a database object like tables. Okay, so if you create the similar, so if I try to create one more with the same index name, it will not accept because this is already exist. Okay, so covering index is like a non-clustered index, right? Just we are including the columns whatever we want in the query, but we have to make a simple difference. Okay, so if you see here, now we have created 3 indexes, which is one is clustered and second one is non-clustered, and this is a covering index, right? So I just make a simple difference here, then only it will accept. Okay, Nandi? So this is how we are creating indexes, and we can be able to see the execution plan, what is going to happen in the background. Okay. So in real time, just we will be creating indexes. That's it. Okay. But for the interview, everything is important. Each and every point is important. Like they will expect to to explain all the backend steps, and sometimes they will be asking about execution plans as well. Okay, Nani? Till now, we have any doubt? Hemant bro or Hare Krishna?
No.
Okay, so this is the advantage of creating index on the top of table. Okay, but because of creating index on top of tables, we also have one drawback. Okay, so the drawback is fragmentation. The drawback is called as fragmentation. Okay, so what is mean by this fragmentation means, for example, so in this example we have 1,000 records, right? So on top of this 1,000 records, we have created a few indexes. So as you see now, now we have created some indexes on top of this sample data table. Okay. So after creating the indexes, so if you create index, what will happen? If you create any index, what will happen? It will store the addresses in in different location, and it will store the data in different location. Aunandi?
Yes.
So if this fragmentation will going to happen, when it will going to happen means, for example, here we have 1,000 records. On top of this 1,000 records, we have created some indexes. So after this, after creating indexes on top of one table, if any transactions has been done, transactions is nothing but it may be insertions, it may be deletions, or it may be updations. Okay. For example, some 500 records has been added on top of this table after creating index. Okay. So now in this, for example, now in our table, some newly 500 records has been added newly. Okay. So what will happen at this time means, on top of these 1,000 records, we have addresses. Avuna,
Yes.
but for these 500 records, where these 500 records have to be stored, it should be stored in the leaf nodes, right? So in leaf nodes, we'll be having actual data. So now this 500 records has to store in some data page, in some pages. So after this 100, after completing storing this 100 records, it will start splitting into different pages to store these newly added records. Correct, Andy? So, but the thing is, So on top of these newly added records, index will not be created properly because these records are added after creating index on top of our table. Okay. So for these 500 records, index will not be properly applied. So because of that, for these 500 records, it will not contain addresses in the root nodes. Okay. So
Okay.
in that case, if we apply filtration on top of any, any of these newly added records, at that time it will perform scan obviously because it doesn't have addresses in the root nodes.
Root nodes.
Okay, this is like somewhat a drawback only, right?
Okay.
So at that time, what we have to do means we have two powerful ways to, to overcome this problem. Okay, so the two powerful ways are rebuild and reorganize. Okay, so by using this rebuild and reorganize, we can alter the index. Okay, so what this generally fragmentation will be measured in percentages format. Okay, so for example, this if these 500 records are added here, okay, let us assume like after 1000 records, these 500 records will be storing in different pages as per the data page size. Okay, so this process, this process of storing data in different pages is called as page split. Okay, so this data will get just generally it will split into different pages, right? So that is nothing but page split here. Okay, so the process of page splitting is called as fragmentation. Okay, Nandi?
Okay.
All this should be explained in the interview or not useful for real time. Okay, Nandi?
Okay.
So this process is called as fragmentation. To reduce the fragmentation is nothing but if records are more, then fragmentation will be high. Like if the records are high means if the newly added records are high means it will be splitted into multiple pages, right? So at that time fragmentation will be more. So generally fragmentation will be measured in percentage format. We have a query to check the fragmentation. I'll show you that. Okay, Nandi? So if the fragmentation is more than 30%, okay, if it is more than 30%, then we have to reorganize the index. Okay, so
Okay.
reorganize means, sorry, we have to rebuild the index if the percentage is more than 30%. Okay, rebuild is nothing but what rebuild will do means it will drop the existing index on top of our created, wherever we created index, on top of that table, it will drop the index and then it will recreate the index again by including all these newly added records. Okay, Nandi, at that time, so if it is rebuilding means just it is recreating the index again, including all new records. So that for these new records also it will have addresses, right?
Yes.
You are getting right.
Yes.
So at that time it will obviously perform seek operation whenever you apply filtration on top of this newly added records. Okay, so that is nothing but rebuild. So in that way we can reduce the fragmentation. Okay, we can overcome our problem. So in case if the fragmentation is less than 30%, okay, at that time what less than 30% means some transactions after creating indexes, transactions has been done very less. Okay, so at that time it will at that if you check the fragmentation, it will be less than 30%. If it is less than 30%, then we have to reorganize the index. So reorganizing is nothing but it will just reorganize, just it will move these pages, newly added pages into these existing pages.
Okay.
It will try to rearrange the newly added records into these index pages only. Because the pages are less, because if it is the less than 30% means obviously the page splits might happen very less. So that we will be reorganizing it. So if it reorganizes means all these newly added records will be merged into this index pages. So at that time, obviously it will also have indexes. For all those records, it will contain addresses. Okay, Nandi. So in these are the two ways to overcome our drawback. Okay, so I will show you how to check the fragmentation and how to rebuild and how to reorganize. Okay. So can you note down the content? So in interview, this will be a separate question. Like sometimes they will ask you about the indexes. So when they ask you about indexes, what you will say? You will explain all the things like backend steps, clustered index, non-clustered, difference between clustered, non-clustered, and what is mean by covering index, and what are the execution plans happening. Okay, sometimes they'll specifically ask you about the drawback. Sometimes they will specifically ask you about the drawback, or they'll just mention what is meant by fragmentation, and sometimes they will ask you about the page split. So is there any ways to overcome the fragmentation? So at that time we have to tell about all these things. I will tell you the theory now. You're getting my points, right? Hare Krishna bro, Hemant bro.
Yes.
So if you
Yes.
have any doubts, please ask. Okay, please note down the content. Keep side heading as fragmentation. Okay, please note down the content. For a first point, this is not a point, just I will explain you a complete theory so that it will be helpful for interview. Okay, Nani?
Okay.
If we have some 1,000 records in a table, if we have some 1,000 records in a table, on top of that we have created index. On top of that we have created index, but after creating the index, some transactions has been done. Some transactions has been done, like it may be insertions or it may be updations and deletions.
Create a index.
On top of that we have created index, but after creating index some transactions has been done. Some transactions has been done, comma. So at that time, on top of newly added transactions, index has not been properly created. Full stop. So the pages on which index has not applied. So the pages on which index has not applied is called page split. So the pages on which index has not applied is called page split. Full stop. This page split process is called as fragmentation. Next point. In indexes, fragmentation is one of the drawback. In indexes, fragmentation is one of the drawback. Next point. To reduce the fragmentation, we will be doing defragmentation. To reduce the fragmentation, we will be doing defragmentation. Next,
We will be doing
defragmentation. Defragmentation is nothing but just we will be reducing the fragmentation by using these two methods. Next point. There are two powerful ways to do defragmentation. There are two powerful ways to do defragmentation. First one is rebuild, second one is reorganize. Next point. Generally, fragmentation will be measured in percentage format. Generally, fragmentation will be measured in percentage format. Next point. When the percentage is in between, 5 to 30%, then we will do reorganize. When the percentage is in between 5% to 30%, then we will do reorganize. That is IE semicolon petkondi. Reorganize will merge the pages into the index pages. Reorganize will merge the pages into the index pages.
Merge the pages into
Index pages. Next point. When the percentage is above 30%, then it will do rebuild. Then we will do rebuild. That is rebuild will drop the existing index. Rebuild will drop the existing index and it will recreate the index. By including all the pages together. Rebuild will drop the existing index and it will recreate the index by including all the pages together. Next, syntax to reorganize the index. Syntax to reorganize the index if percentage is greater than 5 and if percentage is less than 30. If it is in between 5 to 30%, then we have to reorganize the index. Further, please note down the syntax. Next, note down the syntax for rebuild as well. Done, Andy?
Yes.
Okay. Next, so if you want to check the fragmentation, then we have to use this query. So one second. So is this view started for you?
No.
No, right? Okay. We have to know about the views before checking the fragmentation. Just note down this query. This is used to find the fragmentation. Okay, fragmentation is nothing but uh, this is this is a drawback for index. Whenever we create index and after creating index, if something happens, if any transactions has been happening, or a pay split will be happen. So because of that, what will happen? As I said here, so because of that, index will not be created on top of the newly added records. So that's why it became one drawback here. So for that, so if you want to check that fragmentation, like how much percentage is there, like how many page splits has been happened on top of that, pages index has not been applied, right? So that will become one drawback. So for that, we will be measuring that in fragmentation. So to measure the fragmentation, we will be using a system defined view. Okay. So if you go here, generally you will understand this after views classes only. So if you go to the views and if you see the system defined views, you will be having so many views here. Okay. So we will be using one of the system defined views to check the fragmentation. Okay, Nandi. So now you won't understood this. Just note it down. Okay, Nandi. So here for this system defined view, it will accept 5 parameters should get passed. Okay, so all those 5 parameters I have mentioned here. This database ID is nothing but whatever the database you are specifying, right? So that particular database we have to specify here, and whatever the on top of which table we are going to create index on just the particular table we have to specify here. Okay, so table is an object, so we are just mentioning that specific object name here. Okay, and for the rest of the parameters we need to pass null. Okay, Nandi. So don't worry about this query. Just note down this query. After completion of this, you'll get understood this. Okay, Nandi. So if you want to check the fragmentation, just mention your database here, database name here, and then you have to specify your table name here. Okay. రాసుకుంటున్నారా ఇది? Okay. Done, Andy.
Yes.
Okay. So now on top of this sample data, we created few indexes, right? So after creating indexes, if some transaction has been happened, for example, we will also insert some data. So we'll insert some. I will insert some random numbers. Okay, so just I will add some and run a new record into this table. So on top of this record, it doesn't. Index will not be properly created, right? So for this, it doesn't have any address. Okay, so now we will check the fragmentation. Generally, fragmentation will be checked by using this query. So if you see the fragmentation here, So we have object IDs. Object is nothing but whatever the table we are using. Okay, on top of which table we have created index, that particular object ID will be displayed here, and we are calling index ID. So these indexes IDs are nothing but first which index we created cluster index. That particular index have this particular index ID, and this is for second index, and this is for third index. Okay, so we have to focus on this average fragmentation in percentage. Okay, so this average fragmentation, if it is greater than 30%, then what we have to do? So for both these indexes, it is showing as 0. So so if you see here, it is 66.66%, right?
Yes.
So if it is greater than 30% means, then blindly we have to go and do rebuild. Okay. So if it is greater than percent, what?
Yeah, we use rebuild.
Rebuild. If it is less than 30% means we can do reorganize, because reorganize means if the number of page split is less, so that's why we can do reorganize. Reorganize nothing but just it will match this newly added records into these index pages. If it is greater than 60% means page splits might be more. So that's why we will be rebuilding it. Again, it will drop the index and then it will recreate the index. Okay. So now to rebuild the index, we will be using the syntax alter index, and then we will be using we'll be specifying that particular index. So this is the index, right? Index name on top of each table, sample data. Okay, we will execute this. Command executed. Now we will check the fragmentation. If you see here, now it got reduced, right?
Yes.
This is how we will be reducing the fragmentation. Okay, Nandi?
Okay.
So this, I mean, in real time, we won't be working on this. Like we will not be doing any defragmentation and all. Just we will be creating the index. That's it. Okay. So, but in interviews, sometimes they'll ask you about fragmentation as well. At that time, just you have to give the theoretical explanation. That's it. Okay.
Okay.
And then, and this is a stored procedure actually. All this you will get, you will learn in future. Like in SQL, we have stored procedures. Okay, so this is the main concept which will play a key role in our SQL. Okay, in this stored procedure, we will be using all the things which we have learned in SQL. Like we will be calling joins, we'll be calling set operators, we'll be using identity property. So we'll be calling so many string functions inside one stored procedure. Okay, so this T-SQL is nothing but it will it will add some extra features to the SQL. That's it. Like it is also a language with here in each and every concept except indexes in views, or if you take triggers, if you take for functions, or if you take store process, in all these topics we will be using you will be using all SQL topics which you have learned. Okay. This is like basic, this is like advanced. That's it. Okay, Nandi? And these indexes and transactions might differ. Okay, so in these transactions, we'll be having isolation levels, concurrency problem. These three comes under one topic only. Okay.
Okay.
So this is all about indexes. So if you execute, this is actually a system defined store procedure. Okay, store process is generally denoted by, it will start with SP. Okay, so you'll understand this later. So if you want to execute any store procedure, then you have to use exec command. Okay, so why I am using this sp help index means this will show you how, I mean, on top of which, if you specify the table name while calling this sp help index, so on top of this table, how many indexes has been created, it will display that. Okay, let's see. If you execute this particular query, we will be getting the index, different types of indexes which we have created. Okay, now just if you want to see the indexes, then we will be using this query, or else we can just see, check here also. Okay, Nandi?
Okay.
Okay, if you have any doubts, you can ask me. So you're getting my points, right? Like, is it clear or is it confusing?
Yes, it's clear.
For you both?
Yes, clear.
Okay.
ఒక చిన్న డౌట్ ఉంది. కవరింగ్ ఇండెక్స్ అనేది నాన్ క్లస్టర్డ్ క్రియేట్ చేసిన తర్వాత క్రియేట్ చేయాలా?
Yes. So after creating non-clustered index only, we will be creating a covering index, because when we will be knowing about key lookup. So if you I mean, if you have created a non-clustered index, and
Yes, yes.
if you see the execution plan, there will be key lookup performed sometimes. Okay, so when that key lookup perform, so why it is performing key lookup, for to get which columns data it is performing key lookup, at that time only we will be covering that particular columns in the covering index.
Okay.
Okay, Nandi.
Okay. Yeah.
That's it. So as when it comes to the interview point, if they raise a question on top of these indexes, then you have to feel very lucky, because we can eat the interviewer time. At least for 10 minutes, we can explain about the indexes, right?
Yes.
So then we have to feel very lucky. And without raising questions on this top of this concept, no interview will get finished. I'm sure. Like I attended so many interviews. In each and every interview, they will raise question on top of this index for sure.
Okay.
Okay, so that much important indexes is, and in real time we will be creating indexes as well.
Okay.
Depends upon the requirement. It depends. Okay, Nandi. So
Okay.
any doubts? And one more thing I forgot to tell you, we can drop the indexes as well. Like we can drop, generally we can drop like this also. Like I mean, in GUI we can drop like this.
Yes.
Now this, if you want to use any query means, then have to, it is just like table, dropping table. How you will be dropping table? Drop table name, right? So in the
Yes.
similar way, indexes will also be dropped, but we have to specify drop index name, and after that we have to specify which, where it is located, in which table it is located. We have to specify the table name also. Okay.
Okay.
So now this index will be dropped. If you see here.
Yes.
Okay.
Yes.
Now, so
Okay.
that's it. Okay. We close the session.
Yes.
Okay.
Thank you. Bye bye.
Mm.